Well, hello there and welcome back for more Advent of Code 2022. Still 2022, December 28th. But we are running out of days in this year, and I doubt that I will complete the rest of the puzzles before 2022 ends. But that's fine. I haven't been following these puzzles on a daily basis, so I don't feel any pressure really to finish them in a timely fashion. So let's continue where we left off. This would be day 13, lucky number. Distress signal. All right. You climb the hill again and again try contacting the elves. However, you instead receive a signal you weren't expecting, a distress signal. Okay, cool. I hope you always have to respond to distress signals, at least if you're playing FTL. I hope that this is a reference to FTL. Very, very good game, by the way. Your handheld device must still not be working properly. Well, no surprise there. The packets from the distress signal got decoded out of order. You'll need to reorder the list of received packets, your puzzle input, to decode the message. Your list consists of pairs of packets. Pairs are separated by a blank line. You need to identify how many pairs of packets are in the right order. For example, so this is an example input. They look very much like JSON lists. And I'm already thinking about how I'm going to parse these things. And thinking about using a JSON parser, but anyway. So, okay, and the list can be nested, it seems, very nested. Okay. Packet data consists of lists and integers. Okay. Each list starts with starting left bracket, I guess, ends with right bracket, and contains 0 or more comma-separated values, either integers or other lists. Each packet is always a list and appears on its own line. Okay. When comparing two values, the first value is called left and the second value is called right. Then, if both values are integers, the lower integer should come first. Should come first from what? If the left integer is lower than the right integer, the inputs are in the right order. Okay. If the left integer is higher than the right integer, the inputs are not in the right order. Otherwise, the inputs are the same integer. Continue checking the next pair of the inputs. Okay, makes sense. If both values are lists, compare the first value of each. If both values are lists, compare the first value of each list, then the second value, and so on. If the left list runs out of items first, the inputs are in the right order. Okay, so if the left is shorter than the right, then and all the items have been equal till that point, then left is less than right, I guess. If the right list runs out of items first, the inputs are not in the right order. If the lists are the same length and no comparison makes a decision about the order, continue checking the next part of the input. Okay. If exactly one value is an integer, convert the integer to a list which contains that integer and as its only value, then retry the comparison. For example, if comparing the list 0, 0, 0 and 2, convert the right integer value to 2, a list containing 2. The result is then found by instead comparing 0, 0, 0 and the list with 2. Using these rules, you can determine which of the pairs in the example are in the right order. So, okay, if we are comparing this list with this list, I guess this is going to be less than this because of the 3, comparing the 3 and the 5. Yes, okay. So the inputs are in the right order. Okay, so we need to determine if they are in the right order if the first item is like less than with these rules to the right value. For list 2, we're comparing these two, so I guess we're going to compare these two as equal. Then this we are going to compare with 4, which needs to be converted to a list of singleton 4, and then compare 2 with 4, and since 2 is smaller, then they are in the right order. Okay, and so on. Let's see that there was a case of empty. Yes, this one. We had two empty things. We compare the first value of the two. Okay. Right side ran out of items, so inputs are not in the right order. Okay, so we don't have any example of equal inputs, I guess, or equal values. And let's check the inputs. Actually, oh, okay, the inputs contains much longer lists. But hopefully it won't contain any equality. So equality is kind of not defined here, and I wonder if that will play some role in part 2. Okay, what are the indices of the pairs that are already in the right order? The first pair has index 1. Okay, obviously. The second pair has index 2, and so on. In the above examples, the pairs in the right order are 1, 2, 4, and 6. The sum of these indices is 13, like the day number. Nice nugget there. Determine which pairs of packets are already in the right order. What is the sum of the indices of those pairs? Okay. So this looks like implementing a comparison function, if I'm not mistaken. Let's copy these inputs and let's jump into it. So we're gonna go to Advent of Code 2022. I'm using J there as a quick CD. I think this J is an alias for sed command. Let's see. Well, I don't have a manual for that, but yeah, it's a convenient thing to jump around. Let's open the code editor. Well, I have many things opened here. Let's close everything. Let's create an input file for this. This will be day13 txt. Copy the sample, and also create a module for this. This will be day13, and it's called distress signal, I think. Yes, distress signal. Distress signal. Let's copy this and create a file with its name. Cool. And let's use it here. So we're gonna have the usual public function run that takes an input, it's a string slice, and return a string. All right, and as usual, let's reload this thing. So the first thing we would need to do is to do some parsing, I think, unless we can cheese it somehow and like not parse anything and keep these things as strings and then do comparisons like character by character comparison. I wonder if that would be possible. So the list contains some 2-digit numbers. Only 10, it seems to be the highest integer. Let's search for 11. There's no 11. There's no 12. So I'm thinking that, yeah, maybe the numbers go only up to 10. Interesting. Yeah, I wonder if we can cheese it somehow and compare things as strings directly. Would that be possible? I do wonder. Because well, if you compare them directly as strings, the 10 will not be will be less than E2, for instance. So that doesn't seem a promising alternative to parsing. So I guess we will need to parse these things, but man, I really don't fancy doing like a parser, implementing a parser for these things, because these are nested structures, and well, I would have to do something very hacky to do that. I'm very tempted to use like a JSON parser for this, and then maybe implement some bespoke parser. I don't know, recursive descendant parser or something like that. In order to implement that, I would have to read and understand about recursive descendant parsers. So let's actually search for Rust JSON parser. Yeah, there is this library called CERD or CERDE, and there's also a JSON thingy. Let's see what this is about. I'm pretty sure that, yeah, this is an external crate. Rust doesn't include a JSON parser in its standard library. Yeah, I guess there's a thing about Rust crates that sometimes frustrates me. That I don't know if this crate, like the quality of this thing, if it's a alpha quality thing or something that many people use and it's already battle tested, and it's fine to depend on this. There's a result type. Like, what does this thing return? Like a JSON value. What is a JSON value in here? Okay, there is an enum for this. I think we could probably use this library. Probably CERD has a very similar thing. But CERD is a more fully fledged thing. Like, it tries to serializing and deserializing Rust structs into JSON or any other serialization format, I think. Search for cargo, install instructions. Okay, so yeah, I just need to. It was in the first part of the README. I should probably install it this way. And constructing JSON values. Can we just have an example of parsing? Yeah, this is, I think, what I want to do. Operating on untyped JSON values. So there is also an enum that does this. Fine. Sort the JSON from string. Very good. Yes, okay. I think we can probably work with this and this enum. So let's try with JSON as a dependency. I wonder if I can do something like cargo add serve the JSON. Is this the name? Yes. Well, something is happening. Fetching the dependency. Let's check the so there is this value enum here. Sure thing. Why does it need to fetch so much stuff? I wonder. Maybe I have never used cargo as a dependency manager. Come on. Okay, it did something. Let's see what it changed. Actually, it's added this dependency here, fine. And I guess it also added a JSON cargo lock. Fine. So let's use it. And let's try to parse this thing and see what we get. So first we are going to divide by pairs. Let's say, let's value, or let pairs be input split by double new line, and then we're gonna have this string and we are gonna again split, or well, get the two lines, I guess, or let's say split once, maybe, by new line. And let's have left and right. We're gonna expect this. Yes, a pair of values, and I guess we can do, what was the name of this function? Start JSON from string. So we could have a start JSON from string, yeah, left and right, and it's pretty hot in this room. It's kind of sunny, but also I'm feeling quite hot in this Buenos Aires summer. Okay, so we're gonna have pairs which will be samples of this, and I guess this thing probably returns a result. So we can probably do something. We should also, let's just simply unwrap these things for now. And we're gonna collect this into a vector. Okay. What are you complaining about? Needs some type parameter, but the example doesn't need that. I wonder. Cargo run the not one. Well, it's building. Needs to build third. It seems let's run the 13. Parents the T. So what is the T? Instance of T, but can you just parse a plain value? Or do I have to say something like value here? Well, I guess this should be the syntax. Do I have to do that? Interesting. Yes, okay, here it's typing this like this. Okay, I guess we could say, I don't want to call this thing just value in here. Let's just use this and have this thing be a tuple of third JSON value and third JSON value. Very explicit, because I'm probably going to define a value of my own or something similar. Value is a very ambiguous name. So we have this. Let's actually debug print this. Print-ln, and let's print this thing. Let's see what we got. Okay. Yes, surely you can parse this input. Okay. Let's change this and wraps to expected a JSON value. Okay. I guess we have to we'll have to convert this. We can probably implement our own. So I want to have our own data type and implement the comparison function for that thing, so we know which pairs are in the correct order. So let's sketch it out. We're going to have a new enum value, or I guess it could be packet data or something like that, but I think value is okay for this. That's either going to be a number, and let's use, these are very small numbers, so I think they are all positive. Let's take a look at the input, not this input, but the real input. Is there any negative values? There aren't, so yeah. So the next value could be anything. Let's use 32 bits unsigned integers, why not? So either a value or a list that will be just a wrapper around a vec of a value. So that's the recursive nature of this structure. And let's define a function parse value. It will take a string and we return, you guessed it, a value. And it's inside of this function that we are going to do the third, like this third JSON parsing is going to be tucked inside of this function as an implementation detail, but I would like to then get rid of this because I want to have these solutions not have external dependencies. So here we're going to transform this into parse value of left, and same thing, parse value of the right. Great. And this is going to be a tuple of values, not third values. Let JSON be a third JSON value. It's going to be this. Here we are parsing this string. Great. And what are we going to do? So we are gonna match, probably match on this JSON, and so either gonna be a third JSON enum or no value number of n, and what does this number have inside? So any kind of number. Okay, so we're gonna wrap it with our own value number. I wonder if this will work, or we have to do some type conversion here, or an array of values, and I guess here we're gonna make a value of type list, and we need to cast these values. So we could call this thing JSON values and have something like JSON values. So what is the type of this? This would be a vector of value, okay. We're gonna iterate and map with, well, we would like to have a function that converts this JSON to our own values, right? Yes. So let's imagine that this function exists, JSON to value. Then we're gonna collect. Okay, this should be JSON values actually. Okay, and I guess this thing won't be exhaustive, so we have to get anything else and assume that this is unreachable. Unexpected JSON value. Well, of this JSON. Cool. Right. So this thing doesn't exist. Let's actually declare this function inside of here. JSON to value. It's gonna be a function that takes a JSON thing and does this matching for us. Actually, it's gonna be this recursive thing. I think. Yes, and then call this JSON to value for our JSON thing. Does this work? So it found this struct number. So what is that number thing? Has this n. So can we typecast it as U32? So what does this n have? Oh, okay. We can convert it to different types. There is U64, so maybe that's what I'm going to use here. I am fine with that. And you don't like this because this is an option. Let's unwrap this thing. JSON to value in the scope. I guess closures maybe cannot be self-recursive. So let's actually put this thing as a function in here. Then JSON to value is going to take a JSON, which is going to be a third JSON value, and it's going to return the value. Actually, I deleted that match. I didn't want to do that. Let's put all this match inside a bracket. Remove this, and again return a value. Okay. And type is mismatch. Yes, this should probably take references to these things. Let's pass a reference here. And okay. So now we have pairs. Let's derive debug. Derive debug for this, so we can pretty print them. So let's see if the conversion from JSON to our own values words. Can we maybe pretty print them? Well, I don't know if this is much prettier, to be honest. It's more confusing. So let's see. So the first thing is a list of 11311, yes, and then 11511. It looks like, yeah, it looks like it. So okay, we have a list of pairs. Now we can do the actual logic here. So what are we going to do? I guess we can try to implement the comparison, like the ordering traits. So let's see, if we say impl ord, I think, for this value thingy. Let's see. Implement missing members, of course. So I'm not exactly sure if let's actually import this ordering thingy. Yes, import this. And you don't like it because why? It requires equality. Okay. I guess you could derive this. What else do you want? Partial ord. Okay. I never understand why the difference like between partial ordering. I guess this is for total order sets. And partial ordering would be things that can be equal. So what is the ordering enum here? Less, equal, or greater. Okay, so can we... No, I don't want that. Can we implement then... I wonder if we can derive partial. So EQ doesn't also like this, because I guess you need to also derive partial EQ. And can you derive partial ord? It seems like it's. That's cool, I think. So we only need to, yeah, look at that. You can derive partial EQ, which I hope that it just calls the, or sorry, partial ord. So I hope that this just delegates to the ord implementation. So we have to compare now self to other, which is also known as self would be left and other would be right. So how do we do that? Let's follow the rules, or try to remember the rules. So we have basically different cases for these things. I think this is a good... I don't know how I managed to change this, to break this here. Okay. This is a good use case for match, and I guess we can match self and other if they are both numbers. I'm tempted to say using these things. So, you know, it's our values, so we can probably refer to them with shorter names. So if they are all both numbers, left and right, we are just gonna compare those two numbers, I guess. Left, CMP, right. I wonder if Rust has the spaceship operator. Does it? Oh, there's a fat arrow thing, so let's use simply. Okay. Yeah, so if the two numbers, yeah, we're just comparing those two, and if they are equal, we are going to keep on going because we would be actually comparing a list. So let's think about the other examples. The other case is if, well, if they are two lists, let's say a list of can we? I don't think we can pattern match vectors to slices like this. If they are two empty lists, for instance, can I say something like ordering equal? I wonder. Alright, a slice found vec, blah blah. Yes, okay. Left values and let's call it ls and rs, shorter names. So if they are two lists, then we're gonna have some different logic. So can we, I wonder, do pattern matching by splicing those lists? So have a nested match where we're going to have a slice of the left vector and a slice for the right vector, and then do something like, okay, if they are two equal things, I wonder if it's necessary to do this. I guess it's something that the example doesn't really define. So how do the rules say this? If the left list runs out of values first, then the inputs are. So let's say if the left is anything, is empty, then we're going to say ordering less. Similarly, if the right is empty, then we're going to say greater. And if we have some left values and some right values, I wonder if you can do something like this. Can you splat it like this? Not really sure. We're going to compare left compare it to the right. And can we nest this comparison like or else? What are these things? Come from blah blah. Then, when it's not equal. Yes, it's not other. What? Let's check then with. Self, if they are not equal. Yes. Okay, so if yes, I think this is what we want. So if the numbers are different, then we are going to have this comparison. Otherwise, we are gonna compare the rest of these lists as lists. So we're gonna do something like, but we need to, we will need to take ownership because these things take vectors, janits. So let's see. You can probably extract this thing, and this is not specific range pattern syntax is experimental. Okay. How are we going to do this? And I'm sweating quite profusely. Let's extract this thing into a function. No, sorry. Into function. So we're gonna call this compare lists. And we're not actually going to pass the slices of these two. So we're actually going to get here slices of values, I think. And it's gonna return an ordering, I think. So yes, we are gonna pass these arrays converted to slices. I don't think this is necessary. Great. And now this is also not necessary. Okay. Check this thing. Slice patterns. The old semantics. Okay, so I think I just confused the ordering of this operator. Does this work? Not really. I'm not really sure what I'm doing here. So is there something differently that we can do here? I don't want to fight Rust syntax. I think slices have a split first. Yeah, that returns optional first item and then the second one. So I guess we could do something like split first. And we're gonna have let's if it is some L left head and L rest, or I guess tail. Else it means that the list was left list was empty, so we're going to just early return ordering less. Let's do similar thing but with the right. So here to right head and right tail. These are the right values. Split first, and if the right has run out of items, we're going to return greater. And then otherwise we know that the lists are not empty, so we can compare the left and the right values. I don't know, I'm okay, confusing the shortcuts. Left head, let's compare the heads first, and right head. And if they are equal, then we are going to compare lists with the rest. So left rest or tail, sorry, and right tail. And look at that. Okay, so this is not exhaustive, of course. We have two other possibilities. So one possibility is that the left one is a number. So yes, let's say left number, and the right one is a string. So a list of right values, or I guess we can, yeah, okay, let's call it like that. In that case, what we are going to do is, I guess, compare as lists. Well, one of the lists is just the it's a number with the left number. Now we're going to pass this as a slice, and the right is just the right values, I think. Not compare lists. Can't you do this? Well, we can dereference here, of course. Okay, and we need something very similar, but the other way around. So if we have a list on the left, which would have these values, and a number on the right, which would have the right number, we're going to do something similar, but pass the left values and the, again, a slice containing just the right number. Okay, now this is an exhaustive match. Good. Very, very good. I wonder if there's a better way of writing this. Probably there is. But I'm happy with that for now. Let's see if actually we have implemented something that makes sense. So we are going to compare all the pairs and accumulate their indices. So let's see. Ordered, let's see, let's ordered pairs indices is gonna be pairs iterator enumerate, so because we need the indices. So we are gonna filter. So we have the index and the pair of left and right. How are we going to filter this? Well, when the left is less than right, I wonder if we can do that. Then we are going to map this thing to the index, and we are not going to use the pair. Yes, and then, well, that's it. Let's collect these values into a vector. This map doesn't work because yes, it should take a single parameter. Good, we are not using the index here, so let's do it like this. And let's print this thing. Println indices are actually we need to map to index plus 1 because this is one indexed. So ordered pairs indices. We cannot print this. Can we debug print it? Not really. So let's pass it like this and let's run. Oh, okay, look at that. I think that's what we want. 4 plus 6 is 10, 13, no, this is 14. Did I screw it up? 1, 2, 4, and 6. The sum of these indices is 13, is it? Oh, yes, I am. No, but it gave me different indices, 1, 2, and 1, 3 here. Oh, interesting. So, why? So it didn't consider this, like that should be in the right order, right? Yes. And it did consider these in the right order. So I think we are confusing stuff here. So okay, this is the case where we are comparing 1 and 2. So it should be less. Oh no, sorry, we're comparing this one to this one, and then we should make a slice for this and compare this to this. So this should be the case where we have a list and then a number. So this thing we are going to have two values, and then we are going to compare those values. And the left should be less, because it's going to be 2, it should be less than the 4. Interesting. So we got these two cases confused. So let's actually get the pairs, but only get the second and third. Okay, and let's print debug this like crazy. So here we are comparing and self and other. Let's go with this. What the hell? Didn't print anything? What happened there? Was this not called? So that's the partial EQ derivation not called this, like what happened there? Let's see. This method says using the left operator. Sure. I do wonder though. Let's make a quick test for that. Partial ord for value. So we're not going to derive this thing. Implement Misc methods, and this is going to be just comparing. So we're going to return sum self compare to other, and just like that. Let's run again. Oh, it changed the index. What the hell? Let's print the full indices again. Oh, look at that. Now it is 13, the sum. So I don't know what the derive partial ord was doing there. But okay, I'm glad that this fixed the thing. So I guess when you're calling less than, where is it here? You're calling the partial ordering, not the total ordering thing. But well, here we are just delegating. That's good, I guess. And did it actually print what we... Yes, it printed the comparisons. So we could actually probably follow when we were comparing these two things. We compared the lists of number 1, yes, yes, and well, then it compared the other stuff. Okay, so I think it's, well, let's print the answer actually. So order pair indices, pairs indices sum, which would be view size. Instead of collect, we are just going to sum these things. And let's format this long variable name. Okay, let's run. So it is 13. We don't need to print debug now. So okay, let's do it with the actual input and see if we got it right. Save and run. I don't know why it needs to do it again. 6011. Let's try this. I have my cat here beside me. Oh, that's not the right answer. Oh man. Okay. How do we debug this now? That's not very good if we didn't get the same answer. So what are we doing wrong here? Let's bring back the printer. Okay, so let's go back to the sample input. And let's also print here in the nested list comparisons. Println comparing ls and rs. Now we cannot do it like this, so let's use debug printing. That's rs. If we run now, what do we get? Is this the sample input? Yes, okay. Oof, it's complicated. So I guess we could do less than. Let result be this, then just print a line and then return the results. Oh, right, so we can probably have an idea of this. Let's see if we are doing the same comparisons in the same order, or if we are doing something fishy. So we are comparing this and this. Okay. Then we are comparing the lists with numbers. And the last thing that we compare is 3 to 5. I guess we can also print the results here, right? So let's say let results be this, then return the results. But before that, let's print ln debug print this. This is not very good without any indentation. Okay, we get less here. Okay, at some point here we get to compare empty strings. Is this correct? Yeah, I guess so. We compare the these. Can I guess say compare lists? Well, we can identify this by this, and I do wonder though, what is the result of this nested comparison? This is very ugly debugging. Let's see. Oh, so readable. Where does this even start? Here. Okay. So we have this, yes, and we are comparing this. This yields equal. Then we are comparing. Why are we comparing the empty lists here? I wonder. Oh, because the. No, I don't really understand that. Okay, so when we compare these two things, we're comparing then the lists with 1 and 1. Okay, yes, we are comparing then the two numbers, they are equal. Then we compare the... Oh, when we compare two empty lists... Oh, we shouldn't say less, I think we should say equal. Yes, yes, right? Yes, I think so. Yes, so if we say here, let's add if ls is empty and rs is empty, it shouldn't be less, it should be equal. Ordering equal. Well, so it's still 13, but if we, well, let's do it with the actual input, and we're gonna have a lot of noise when running this, but now it gives another result, and I wonder if this is the correct results. Yes, it was. Okay, it was a silly mistake. I missed that because of not doing like pattern matching and seeing that more visually. Well, that's an excuse, I guess. I missed it because I suck. Let's return this result here. And let's not do so much printing of stuff. Okay. Oh, so many new lines because we are also printing in here. Let's also go back to what this was before. Only this. Okay. I wonder if for part 2 we're going to need more debugging. Fine. Now you just need to put all of the packets in the right order. Disregard the blank lines in your list of received packets. The distress signal protocol also requires that you include 2 additional divider packets. Using the same rules as above, organize all packets, the ones in your list of received packets as well as the 2 divider packets, into the correct order. For example, for the example above, the result of putting the packets in the correct order is this thing. Okay, we also need to put the divider things. Afterward, locate the divider packets to find the decoder key for this distress signal. You need to determine the indices of the 2 divider packets and multiply them together. The indices of the 2 divider packets. The first packet is at index 1. Yes, the second packet is index 2, etc. In the example, the divided packets are 10th and 14th, so the decoder key is 140. Organize all the packets into the correct order. What is the decoder key for the distress signal? Oh, okay, very good. Very interesting. So I guess we can have, here we have all pairs. We could have the divided packets, so let's see, let's try the packets. It's gonna be, so this is a list of, I guess we could use a parse value. And we're gonna pass this to and parse value. I'm very lazy. And 6. Okay. This, why don't you like this? We are not closing the correct brackets. Okay. So we have these divider packets. And we need to what? We can say let's all packets be pairs. We're gonna flat math, I guess. Do we need to do this? Actually, I don't know if we can iterate over a tuple. Let's see. If we have a tuple here. Oops. Can we do something like pair iter? No, not really. So if we convert it to a value here, I don't know if this will work. So we're going to have this and then chain the divider packets iterator. We're going to collect that into a vector of, I don't know if this will be value or references to value, so let's actually have it like this. Flat map. This doesn't like this because it's not an iterator. Oh, of course, we need to make it an iterator. Well, okay, that worked. It's a vector of value of references to values. That's perfect. That's what I wanted. And I guess we can make this mutable. And let's sort it. All packets, all packets sort. Does this work? It seems so. All right, and now let's find the indices of the divider packets in this sorted array. So let's divider packets indices is gonna be we can actually make something like all packets index. Can we ask for a position? I wonder, do we have to make it an iterator here? Iter position. Well, let's do it like this. A predicate. Well, let's do it in a very general way. So we're going to have a value, and let's filter when the dividers packets contains packet. Oh, I have a typo there. Contains this value. Let's rename this packets. Okay, and then get the product of this product. Yes, this should be a U size, I guess, because it's product of indices. Oh no, since it is the product of indices, it's gonna complain, right? Yeah, we have to enumerate this. And I'm going to get an index and the value, and then we are going to map again to the index and value, index plus 1. Okay, it's not the index. Divider packets indices product. Let's print this. And let's actually go to the sample input and see if we get 140. Yes, we got 140. Let's go for the actual input. Let's see if this is the actual answer. Yes. Nice, nice. All right, so this one was quite fun, and overall kind of straightforward. Besides that problem that we had when the two lists were empty, where we had to make them compare as equal. So I think that's very good. I wonder if we can. No, I guess this is fine. Okay, I'm very fine with this code, I think. Yeah, the using of the third JSON, I would like to remove this. So let's say here to do remove third JSON dependency. This is also good. I guess we don't need to drive debug if you can get the right answers. This was surprisingly good, the flat mapping of this to this. Very useful. Ordered path indices. Some very good. Yes. So I'm quite okay with this code in the main function. Yes, here we are doing the comparison. Yes. Then we are sorting all the packets. And then, yeah, we're finding the indices of these two divider packets. I wonder if we could express this. So let's add all of this. And I wonder if we can express this in a better way. Like, I find it weird to not have a method to get like the index of a given value. This is not what we want. Yeah, I guess that this is fine. Let's keep it like this. Parsing values has this to do. This is also fine. I think we did some unwrapping. Yes, in this case. Well, I guess if this has floating values, but this is not a problem. We have to get rid of third JSON, so this is fine also. I wonder if we can do something better here for the list comparison function. I would like to use match, but I don't know how to capture like head and tail, because I'm pretty sure that you can do something like let's, for instance, something like this equal. Does this not work? But you can do this, right? You can ignore this thing. refutable pattern. Yes, if it's not empty. Let's actually look for that's Rust slice patterns. Daily Rust patterns. Can you do this? Can you capture this? Oh, look at that. Ah, you can capture it with this. That's good. That's good. Let's see if this works. So let's match the tuple with ls and rs. I guess we can check the names that we are using for these two. So if they are both empty, then it's gonna say ordering equal. Then if the left so is empty and the right one isn't empty, you're gonna say ordering less, I guess. Then we're going to say the same thing, well, do the same thing for the other case, ordering greater. And the last case should be when we have L head and L tail. How was this thing? Like this. Or R head and R tail. And in this case, we're gonna do this. So does this work? Well, maybe it does. Let's see. Let's see if we get the same results. We actually do. That's very cool. So yeah, look at that. Head and tail, head and tail. Yes, 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 yes. Very good. And also, Rust is not complaining that this is not exhaustive or a refutable pattern, so I guess it's making sure that this covers all cases, so that's very good. And I think this reads much better than the thing we had before. Fine. This would be the left values. So let's use some more consistent naming here. So here we are calling this right values, left values, and rnum and left num. So we could, I guess, call this in a similar way, left values and r values, and here also call it left num and right num. Yeah, just some consistency in there. And I guess here we can also probably use the same names. Left values, right values. Yes. All right, very good. I think that's, yeah, this code looks pretty good to me, and overall the solution, I'm very pleased with it. The only thing that I would like to change is the dependency, to get rid of the dependency of served. But other than that, yeah, this was a very nice puzzle. So let's commit the solution. Solution for day 13. So, all right, that was a pretty good one. I really enjoyed implementing the ordering logic of these values. Did you not commit? Yes, okay. I don't really understand why I needed to manually implement the partial order traits, and why the derivation of these traits was doing some default behavior that, did something but didn't do what we wanted. Like it wasn't calling this order compare function. So maybe I can read a little bit more on that, or if you want to, if you're watching this and you want to give an explanation, please do so. Yeah, let me know of any other improvements that I could have done to this code. I will not try to implement a parser now. I will leave that for later because I have to run now. But yeah, I think that's it for today. And if you have been, thank you very much for watching and see you next time. Bye bye. Nope, wrong shortcut.